It is possible to have equations with multiple variables in the same equation. I don't know if you knew that. Of course you knew that. I told you that at the end of the last worksheet. An example with more than one variable is never a bother as long as it's a simplified problem. For some reason, when kids have to do simplified problems, the more variables the merrier. Well, actually, I may be getting a little carried away, but they certainly don't seem to mind. Try these two warm-ups and see what you think. One has fractions, at least to start with. Whether or not they'll have them at the end, we can't assume, and one does not. What else is different about them? Here's example 1. We're going to simplify by distributing, combining like terms, and stopping. Put the problem on pause, work it out, and see if you got the answer that I got. One of us is right, and one of us is wrong, or we're both right, or we're both wrong. Who knows? That's the mystery and half the fun. When you're finished, try example 2. Distribute, combine like terms, and stop. After you finish practicing these simplified problems, we're going to go to the next section and we're going to look at the same problems, except we're going to make them into equations. Here we are with example number 3. I took example number 1, changed it from simplify to a solve, and put in an equal sign right in the middle of the problem. The minute an equation has 2 or more variables in it, you need to have some extra instructions. The instructions I chose for this problem were solve for y. What that means is make an answer that starts y equals, and because there are multiple variables, there's going to be other variables in the answer. We start the problem by doing the same thing we do every single time we solve equations. We distribute, we combine like terms, and now, because we're going to be solving for y, we want to move 3x. There's 2 reasons to move 3x. One reason to move it is because there are x's on both sides, and we want to combine like terms, so to speak. And when they're on opposite sides of the equation, we have to do it algebraically, not simply by adding or subtracting. I chose to move the 3x and keep the 2y on the left because it's my personal preference. I have a personal preference that I pretty much follow almost all the time. I do that because I work better when I work the same over and over again. Even if I wasn't willing to keep the 2y on this side, and for some reason I wanted it to be on another side, I could do that, but I still would want the x's to go together. Now, since I chose to keep the 2y on the left, the 8 has no place here, so I subtracted the 8's from both sides and got 2y equals 3x plus 12. There are 3 ways to divide the problem by 2. I could divide the 3x by 2 and the 12 separately by 2 and write my answer in fraction form. Or I could divide the 3 by 2 and write it in decimal form. Or I could keep the whole 3x plus 12 together and divide the whole thing by 1, 2. All of these answers are acceptable answers for solving for y. Since in Algebra 2, as opposed to Algebra 1, you're doing a lot of review and simple factoring is something you already know, I wanted to show you one more solve problem that's a little bit unusual. So I wrote example number 4. Take a second to check it out. It's an equation because there's an equal sign in the middle. There are 3 variables, a, b, and x, so I had to choose one to solve for, and I chose x. So here we are. Again, the first thing I did was distribute, and as you already know, when I'm collecting numbers and variables to make a term, I put them in alphabetical order, number, and then the letters of the alphabet. So even though the a was in front of the 2x, I wrote 2ax, and then I wrote 5ab, and I kept inserting the a into the middle of the problem for alphabetical order. Since multiplication, the order doesn't matter, I can organize it any way I want. Then I distributed the b, and again, in the first one, the b went before the x, and the second one, the b went after the a. It's all according to alphabetical order. Again, once you notice that there's a 5ab here and a 9ab here, you're going to want to put them together. Which one of the 2 you move to unite them, so to speak, depends on your own personal preference. Again, I want the left side of my equation to be for x, because that's what I'm solving for. Since AB doesn't have an x, that's the one I'm going to move. So I subtracted 5AB from both sides, and this is what I got. Now, I need the x's to all be together if I'm going to solve for them, so this term, which has an x in it, can't stay on the right, so I subtracted and moved it to the left. Here comes the very interesting twist to this problem. I have to be able to put all my x's together, but since this is an ax term and this is a bx term, they're not like terms. So the only thing I could do to get my x free is to factor it. So I pulled out an x, as they say, and factored it to the front with 2a minus 3b in parentheses, and because 2a minus 3b is a multiplier of x, I divided by it, and I got my final answer. X is equal to 4ab over 2a minus 3b. Now you're going to try one. All right, so you're going to try two. There's not really too much to say about example 5 and example 6. You're looking at them yourself. I just had to pick, because there were multiple variables, which one I wanted to solve for. In number 5 I chose x, and in number 6 I chose h. And the only thing that was a little bit tricky about number 6 is I put a fraction into the front of the equation, and you always start a equation solving problem by clearing the 1/2. What you couldn't do in simplify, you can do in solve. I would start by multiplying both sides of the equation by 2. That's all the hint I'm going to give you. What you can do now is either pause and switch to the sheet, or stop and switch to the sheet. You have both of these problems on the sheet with the answers I got at the bottom. Please make sure that you check your work and make sure that you got the correct answer, assuming my answer is the correct answer. If not, please try to find, well, you can't find the mistake in my work because I've got my work, but if you think it's you that made the mistake, find your own mistake. The way to become a more effective mathematician is to find your own mistakes. And if you can't find any mistake and you've looked very carefully, then trust your answer. An answer is worthless if you don't trust it.